In this video, we're going to be graphing simple rational functions that contain translations using h and k values. So this is the general form of what a rational function with a translation will look like. So previously we've discussed the equations that look like y equals a over x. Those contained an a value that would stretch or shrink our graph. And now we're going to add in h as something we're going to add or subtract with x. And we're going to add in k as something we add or subtract off to the side. Now, hopefully you're remembering h and k and how translations work from previous graph types, because h and k work exactly the same here as they did before. So here we have our k value and our h value. H being a value that is down here with x is going to be a horizontal translation. And the reason that it has that negative sign here is because, just like in previous graphs, it works opposite of what we expect. So if it's negative, it's going to move to the right. If it's positive, it's going to move to the left. Then here we have our k value, and the k value is a vertical translation. And this one works just as expected. If you're being added, you're moving the graph upwards. If you're subtracting, you're moving the graph downwards. So these placements of h and k, x has h in here in the denominator with it, and k here on the outside, will tell us exactly how this hyperbola is now going to be shifted around the graph. It's no longer just going to be centered with asymptotes at 0 and 0. It's going to be moved around the graph and centered elsewhere. Now, as we graph these, what we're going to be looking for today is we're going to be going through the process of starting with just the simple graph. So we're going to originally get a table for just y equals a over x. So we're going to ignore the h and k temporarily, get a table for those values, and then after that we're going to move that table as well as the asymptotes according to h and k. So let's jump in and look at our first example here. We have an a value of -4, an h value of 2, and a k value of -3. So essentially what I expect to see with both h and k is with k, I expect to see this graph and its asymptotes move down 3, and with h, because it's a positive, I expect to see it move left, so in the negative direction, 2. So to start, I'm going to take a look at just the function with your a value, which is -4. So we have y equals -4 over x. And we're going to start with that simpler function and then translate it to where we need it to be. So again, I'm going to look at the points 4, 3, 2, and 1, and then -1, -2, -3, and -4, just to get a feel for those. So here we have -4 over 4, so our y value is -1. Then we have -4 over 3, -4 over 2, which is -2, and -4 over 1, which is -4. I then also have -4 over -1, which is 4, -4 over -2, which is 2, -4 over -3, and -4 over -4, which is 1. So I've calculated my table of points here, and I have -1 all the way through those positive points down there. Now from here, what I'm going to do is I'm going to do two things as I translate this function. One is I'm going to actually draw my asymptotes correctly onto my coordinate plane here. So normally my asymptotes are at 0 and 0 here. So normally they're at 0 and 0, but they're going to move now. This one is going to move down 3, 1, 2, 3. So I'm going to have an asymptote here that has moved down 3, because that's how the whole graph is going to move. I then have this asymptote here that has moved left 2. So this is going to be the new kind of center point for my hyperbola. It's no longer centered at 0, 0. It's moved left 2, down 3. So the asymptotes follow suit. Then from here, I'm going to take all of my points and translate them accordingly. So all of my x values, which are my horizontal points, I'm going to subtract 2 from, because they're going to move left 2. And all of my y points, I'm going to move down 3, so I'm going to subtract 3 from. So if I create new points here, I subtract 2 from all my x values. So I have 2, 1, 0, -1. And then I have -3, -4, -5, -6. And then for all my y values, I'm going to subtract -3. So I have -4. Then this one, this is really -1.33 repeating. So if I subtract 3 from it, it's -4.33 repeating. And if I continue subtracting 3, I end up with -5 and -7. If I then move on to these points down here, I end up with 1, -1. Again, remember that this is really a positive 1.33 repeating. So that turns into -1.67, and then this turns into -2. So now if I go ahead and plot these, x is 2, y is -4, x is 1, y is -4.33, then we're at -5 and -7. I can see that that's lining right up with my horizontal asymptote here, and then I can see it's lining right up with my vertical asymptote. So that hyperbola really did move just to that location. Then if I go to the next couple points, I have -3, comma 1, -4, comma -1, then we're at -1.67, -2, and this one is doing the same thing. It's lining up right here, and then lining up as it goes upwards here. So you can see both sides of that hyperbola fit right into where our asymptotes move to. Now from here, our domain and range are going to be slightly different because our asymptotes moved. So here, the x value that we can't use, we can see is -2. And the y value that we can't use is right here at 3. We can see that our y values are never equal to those because there is an asymptote there that we can't cross. So our domain is going to be all real numbers, but x cannot equal -2. And our range is all real numbers, but y cannot equal -3. So let's do one more quick example here. So we have our new function. This is our a value. We have our h and our k. What we expect to see is with our k value, our graph is going to move up 5. And with our h value, this graph is going to move right, because this goes in the positive direction, 4. So let's start off with that basic equation of y equals 3 over x. And we're going to create a table of values for that. So we have 4, 3, 2, 1, and then -1, -2, -3, and -4 as the points we're going to look at. So if we start substituting in our x values, we end up with 3/4, which is about 0.75, 3 over 3, which is 1, 3 over 2, which is 1.5, and 3 over 1, which is 3. And then if we repeat that, 3 over -1 is -3, 3 over -2 is -1.5, 3 over -3 is -1, and 3 over -4 is -0.75. So we have our points that we're going to start with. Now from here we know that our asymptotes are going to move up 5 and right 4. So here let's start off by moving this horizontal one that can move up and down up 5. So it's going to move all the way up here to 5. Then we're going to move the vertical one to the right 4. So we can see that this is centered in a new location. Now from here we're going to take all of our points here and we're going to add 5 to them for the vertical change on the y side, and for these we're going to add 4 on the x side because that's our horizontal translation. So now if we go ahead and we get our new table of points here, well, if we add 4 to the ones on the left, we end up with 8, 7, 6, and 5. And then we end up with 3, 2, 1, and 0. Then if we add 5 to the points that are on the right, so those y coordinates, we end up with 5.75, 6, 6.5, and 8. And then we end up with 2, 3.5, 4, and 4.25. So now if we go ahead and graph these, when x is 8, y is 5.75 is going to be about right here. 7, it's 6. 6, it is 6.5, so it's a little bit higher. And 5, it is 8. So now we can see how it's just starting to curve up right in our little asymptote nook there. Then from here, if we do the 4 bottom points, we have x is 3, y is 2. X is 2, y is 3.5. X is 1, y is 4. And x is 0, y is 4.25. So again, it's going right in line with where our asymptotes are and fitting right in that little nook. Now the final thing that we need to find are our domain and our range. If I look at my x values here where my vertical asymptote is, this tells me that x cannot be 4 because I can't cross that line at x equals 4. So my domain is going to be all real numbers except x cannot equal 4. And then my range, I notice that I can't cross y equals 5 here. So my range is going to be all real numbers, but y cannot equal 5.